Okay, so this problem says complete each statement regarding an angle theta and its reference angle. That looks like I cut it off. It should say theta hat using radian measure. Let's see if I can even get this to. Okay, just kind of brought it up there too far. All right, so we got theta hat there. So complete each statement regarding an angle theta and its reference angle theta hat using radian measure. We should assume that theta is between 0 and 2 pi, and then give our answer in terms of theta. So if theta is in quadrant 1, then theta hat, which is its reference angle, should also be in quadrant 1. And to get an idea of this, what we can do is just look at a set of axes here. So let's make an array of our angle theta here. And theta is in the first quadrant. We don't know where in the first quadrant it is, but that's it right there. This is theta. So the definition of a reference angle is the angle that goes to the closest x-axis, and not the closest positive x-axis. If you're in the second or the third quadrant, you would go to the negative side of the x-axis. So the closest x-axis from here, if we make this into a blue color, is actually the same angle. It's theta hat. So theta hat is actually equal to theta. And yeah, so we'll make theta for that one. Let's see. I should have made another layer for this. So just redraw this quickly. Okay, so there we go. And that there, we've got x, we've got y, and let's get it up. Okay, so we can erase cleanly. So our angle here for part B, theta, is in quadrant 2. So we know it's over here somewhere, quadrant 2. We don't know where. So here's theta. The reference angle for theta will be theta hat, and theta hat will be to the closest x-axis. So this right here is theta hat. So it says if theta is in quadrant 2, then theta hat equals. Now what we want to do is write some expression in terms of theta. I can see from this diagram that I drew that theta hat plus theta equals 180. And then if I subtract theta from both sides, actually let me go through the motions of doing that. Subtract theta from both sides, I'll see that theta hat is equal to 180 minus theta. And so what we have is some, we can describe theta hat in terms of theta. That's what we're looking for. Okay. And similarly, if theta is in quadrant 3 now, so theta will be in quadrant 3. We don't know where in quadrant 3. It could be anywhere in here. We'll put it there. Then it asks for to find theta hat in terms of theta. So if theta is in quadrant 3, that means this portion of this angle here is theta hat. So the green is, maybe let's go back to that. So this green is theta, and then theta hat will be the blue portion, which is just this portion here. Theta hat. So what does that look like? We can say that theta hat, let's see, we'll say theta minus theta hat equals 180. Which means that theta hat is theta minus 180. So how can we do that? So we'll add theta hat to both sides. And so theta equals 180 plus theta hat, which is true, but that's not what we're looking for. We're solving for this. And so we'll subtract 180 from both sides. And we find that theta hat equals theta minus 180. So And last one is if our angle theta is in quadrant 4. So we'll draw an angle in quadrant 4 somewhere in here, which means that this big angle is theta. And our reference angle, theta-hat, which is to the closest x-axis, which is here. This is theta-hat. And to me, I can make this expression say that theta plus theta-hat equals 360. You can just see that from the diagram we drew. So if I want to solve for theta-hat, I'll subtract theta from both sides and find out that theta-hat equals 360 minus theta. Okay.